today's class. Okay. So the week's objectives, again, classifying numbers, and then that's what we're doing today, describing patterns and distinguishing between number types. So that's our objectives for the week. We're gonna continue with classifying numbers today, and yesterday I had a list of questions for you guys, but we didn't reach to number 8 and number 9, which is what is a rational number and what is an irrational number. Now, a rational number is all the fractions where the top and bottom numbers are integers. So now what does that mean? That I could have half, 3/4, 7/2, -4/3, and 4 ones. And those are all rational numbers. But we have to bear in mind that for when we say integers, integers also includes a 0. But in this case, if you want to write a fraction, the denominator or the number at the bottom can never be a 0, because then it won't be a fraction anymore, right? We can't have 4 parts of 0. What is 4 parts of 0? Well, 0, right? So moving on, what is an irrational number? Well, an irrational number cannot be written in fraction form. They cannot be written as the ratio of two integers, meaning that if we go back to a rational number, I can write almost anything as a fraction, but there are some exceptions where I cannot write it as a fraction. For example, if I ask you to, if you have a calculator on your phone and I tell you, what is the square root of 2? What is the square root of 5? 0.353535, never ending 35. Those little ellipses, the 3 dots, means that continues. I'm repeating 35 and 35 and 35, and it's never gonna be ending. Can I write that as a fraction? And then we have pi. What does pi mean? Anybody can tell me what does pi mean? What is the value of pi?
3.41.
That's it? Just 3.41? Or does it continue? Nobody knows? Let me show you guys something. The exact value of pi. So I'm gonna share this tab because I searched the exact value of pi, and look at this one: 3.141592653589793238, and it continues and continues and continues. This is the exact value of pi, and it continues apart from that. So pi is a never-ending value. So when we're talking about irrational numbers, is something that I cannot write as a fraction because of the square root. So square root of 2, square root of 5, and you have to be careful because, for example, if you do square root of 2 on your device, it's gonna give you 1.1 never-ending decimal, and I can't write that as a fraction. And if I do the square root of 5, it's gonna give me 2.23 never-ending decimal, right? Just like 0.33353535. But there are certain square roots. For example, if I ask you, what is the square root of 9? Can you tell me what is the square root of 9? Anybody knows what the square root of 9 is? Nobody? Do you know what it is? Very good, very good. It's 3. A square root, when I'm talking, and then we're going to talk about square roots more in depth later on. But a square root is basically, if I have the number 9, I want to know what number times itself is going to give me 9. In this case, 3 times 3 gives me 9. If I want the square root of 4, what number times itself gives me 4?
2.
Very good. 2. And then those are what we call perfect squares, because when I find the square root, I get an exact value. But when we're talking about irrationals, we have to be very careful, because we can't just say, okay, because the number has a square root, that means it's irrational. No, there are certain exceptions, always exceptions to the rule. All right? So, yesterday I asked you guys a question. Can a number be more than just one type of number?
Yes, me.
Yes? How many of you say, okay, let's use the chat. I want you guys to put yes if you think it's yes, or no if you think it's no. In the chat, let's see. And I want everybody to put an answer in the chat. Let's go, guys. Put your answer in the chat. Can a number be more than just one type of number? Okay, so let's see. Let me check. Way at the top. Yes, yes, yes. Okay, everybody says yes. Now I want one or two persons to tell me why.
Because it can be a natural number and
I heard two persons. Let's see. Let's see. One person first and then the other one, because I had two persons I wanted to share answers. If you can't tell me a meaning, give me an example. Like tell me, okay, well the number 2 can be this. That's why I think yes. All right. Who would like to share?
Yes, there could be different kind of numbers. For example, like depend on this. The prime, it's a number that count that let's say it can't be by two. For example, three, yes, goes by one and two. Yeah, they go together, but three doesn't isn't wrong. So basically, there are different kind of numbers.
Okay. So Alan, you are jumping to what I'm gonna be talking about tomorrow, talking about prime numbers. But and you're correct, your answer is correct. It's perfectly correct. But I want you guys to talk about natural numbers, integers, real numbers. That's what we were doing yesterday. So I want to know, is it possible for a number to be real and for it also to be rational? Is it possible? Anybody? Nobody knows? Everybody went blank? We're gonna move on and then we're gonna go back to that question. Because all of you said yes, but you can't tell me why yes. Jennifer Zul. Okay. So here I have a diagram that represents all the types of numbers. So yesterday I had given you guys a little family tree diagram, but today we're going to do it in a more set form. So the circle in blue is entitled real numbers. Why do we call that real? Or why is everything inside of the real number set? Why don't I have anything outside of it? What is it? What do we say yesterday was a real number?
1 to
I didn't hear your answer. I think it's my internet, but sometimes all of your cameras turn off and all of them turn on again. So,
Miss,
yes.
it's a number, a decimal.
A real number?
Mhm.
Miss,
Mm,
because
okay, let's hear your answer. And then I'm gonna hear what everybody's gonna say, and then I'm gonna say what it is. Yesterday.
Miss, I think
I didn't hear what you said, Yuri.
it's a measuring number, measurement number.
Okay, so a real number, we call real numbers measurement numbers, yes, but you guys aren't telling me what is a real number. Do you want to go back to the slide that we were talking about yesterday? Did you forget what we said a real number is? What is a real number, guys? Look at the picture. The picture has real numbers and everything is inside of that big blue circle. So what is that telling you?
Because the real numbers are used to write the others, Miss.
Okay, okay. Everything is inside of the blue circle because all the numbers are real numbers. It doesn't matter if it's root 2, if it's half, if it's negative 5. It doesn't matter because all the numbers are real numbers. All right? So if I tell you, okay, this is a natural number, but guess what? It's also a real number. If I tell you, okay, root 2 is irrational, but it's also a real number. If I write negative 5, okay, that's an integer, but it's also going to be a real number because everything is a real number. All the numbers are real numbers. All right? So, what this is telling you now, and this is how, and I had mentioned about one of the assignments that's a table. I give you a number and you have to check mark all of the ones that that number falls under. So we use this diagram to do that. If I say I have the number negative 3, where in this diagram would I put negative 3? What kind of number is negative 3?
Miss, it's an integer and a real.
It's an integer. Very good. Negative 3 is an integer. So
Miss,
negative 3 is going to come right here where I have integers. Now, because it is an integer and it's right here, that means that it's an integer, but it's also a rational, but it's also a real number because integers is inside of the rational and it's also inside of the real. So if I'm talking about the number -3, what types of number is -3? What did I just say -3 is?
It's an integer and rational number.
It's an integer, it's a rational, and it's also real. So -3 is 3 of them, right? Now let's say I give you the number 10. Where in this picture would the number 10 go under? Or what is the number 10?
Real number in the
Natural
real number.
number.
It's a natural number. Very good. A natural number. So, number 10 is going to come here. But number 10 is going to be natural. Number 10 is also going to be whole. Number 10 is also going to be an integer. Number 10 is also going to be rational. And number 10 is also going to be a real number. So, because number 10 is a natural number, that means that number 10 is also whole, is also integer, is also rational, and is also real, because natural numbers is right here in the middle of everything else. Right? Anybody has any questions? Do you guys need another example? Now, right here. This is the same thing, but only because I'm using
Miss,
boxes.
can you give one more example?
Okay, we're gonna talk about the numbers that I have right here, right? So this one is the same thing as the first one, only because this is in circle shape, and then now I have this one in a rectangle and boxes, right? So if I'm talking about the number 21, where do you see 21 in that picture?
Natural number.
Natural number.
Very good. Under the natural numbers. Now, if I tell you, I want you to tell me all the kinds of numbers that 21 is. What is the different types of numbers that 21 is?
Means it's a whole number, an integer, and a rational number, real numbers.
Okay, you forgot one though. You told me whole, integer, rational, and real. Which one did you forget?
Natural.
Natural, very good. So we have 21 being a natural, being a whole number, being an integer, being a rational, and being a real number. So when you see your little table in the homework, you have to check mark all of those columns, because 21 is first a natural number, and because it is a natural number, it's all of the rest, because a natural number is way in the middle of our diagram. Now, let's say I'm talking about -5. Who can tell me what kind of number? Where is -5 in this diagram?
In the
No, what did I say? Square root of 5,
Irrational
sorry.
number.
Square root of 5. Where is square root of 5?
in
Irrational.
irrational.
Irrational. Very good. Now, if it's in the irrational, we have irrational on the side by itself. What kinds of number would -5 be? Is it only irrational?
Real numbers.
Very good, Valera. It's also a real number. So when I'm talking about -5, then I'm going to check irrational, and I'm also going to check real number, because it falls under both of them. Everybody understands the diagram here?
Yes, miss.
Very good. Now I
Yes,
have a
Yes, miss.
question. I have a question. Why is negative 36 under whole numbers? Who can tell me why? Anybody knows? Is negative 36 a whole number?
It's not, it's not a negative number.
Okay, negative 36 is not negative. Very good. What else? But why is it there? What are whole? If I ask you, okay, write all the whole numbers, what would you write? What are the whole numbers? Do you go 0, 1, negative 4, I'm not negative 4, sorry, square root of 4, square root of 9? Do you count your whole numbers like that? No. So why is negative 36 there? Can anybody tell me?
Miss, I don't hear you well.
Are you not hearing? Is somebody else having problems hearing me? I'm not sure if it's my internet that is giving problems. Okay, let me see. Okay, negative 36 is in the whole number section because, not negative 36, sorry, square root of 36 is in the whole number section because when I find the square root of 36, it gives me a whole number. So the square root of 36 gives me, what number times itself gives me 36?
Six, miss.
Very good, Kevin. It's 6 because 6 times 6 gives me 36. So the square root of 36 is 6. And because the answer is a whole number, that means that the square root of 36 is a whole number. Now, I have 9 over 3 in the whole number section as well. Why is 9 over 3 a whole number?
Miss, because the denominator is larger than the numerator.
Mm. The denominator and the numerator don't really matter in this case, right? There is another reason why it is a whole number. When we looked at the square root of 36, we were talking about the answer. For this fraction, we're also talking about the answer. What is 9 over 3? What is 9 divided by 3?
A whole number.
Very good. The answer is 3, but the answer is also a whole number. So that's why I have 9 over 3 there, because when I have 9 over 3, I need to think, and these are things that you have to do in your head, right? 9 over 3, the answer is a whole number because the answer is 3. So that's why I put 9 over 3 there, right? And then when you get your and we're gonna look at the homework, and then we're gonna look at a few of them, maybe 2 or 3 of them that we're gonna do together so that you can do the rest on your own, right? So let's move on. Anybody has any questions before we go to the first activity? So I have about, I think, 3 or 4 slides that have little activities that we are gonna be doing. All right. So this first activity is color coding. Use the color keys to determine the correct classification of each value. And I have that red we're gonna color code. So you are gonna tell me which ones to color, and I'm gonna be coloring them. So red is for numbers that are irrational. All right? So looking at that table, which number is irrational already? Which number can you tell me is irrational?
Root 60.
Very good, Yuri. Root 60. So I'm going to be coloring that one red because it's irrational. I'm going to color orange the rational numbers only. Yellow, the numbers that are rational and are integers. Green, the numbers that are rational, integers, and the whole numbers. And I'm gonna color blue the ones that are rational, integers, whole numbers, and natural numbers. So we have to be careful when we are choosing what to color, all right? So I'm gonna come over here and let me see if I can make it bigger. Okay, there you go. So we said, and Yuri said that this one, we can color that one red. Hmm? Do you see any other irrational number?
Root 121.
Okay, root 121. Is there any number that I can times by itself to get 121? This is your times table. You should know your times table.
7.
7 times 7 gives me 49.
11 me.
11. Very good. So, if I find the square root of 121, it gives me 11. So this is not an irrational number. It is something else. Let's go to the slide that had irrational. See irrational right here? It could be a square root. It could be a decimal that never ends, and it could be pi. Do I have any of those here?
Pi.
You have pi. Very good. So I'm going to shade it red. Any other one?
9.5. 9.564.
Okay, very good. Anything else?
Fraction, miss.
Remember that an integer is a number that I cannot write as a fraction. Do you see any other irrational number here?
Miss, how about the negative 5.45?
The negative 5.45. I can write 0.45 as a fraction.
Root 121.
We already said that root 121 is not irrational. Do you want to move on to the other one? Let's start here at the bottom with blue. What number here is rational, integer, whole, and natural?
Integer, miss. Negative 47.
Negative 47. Let's see. Negative 47. Is it negative 47? So what color would you color that one?
know.
But negative 47 is not natural and it's not whole, so we can't color it blue.
Yellow.
Very good, yellow. Yellow. Let's go one by one. 0. What is 0? What type of number is the number
A whole
0?
number.
A whole number. Very good. So let me find the one that says whole number. Right here. Whole number, integer, and rational. So I'm going to color this one green. Negative 3/4. What is negative 3/4?
Integer.
Mm, it's not well, it is an integer, but remember that integers are only whole numbers, positive and negative. This is a fraction. This is a negative fraction. What is a negative fraction?